Welcome to IPMWORKS e-learning modules. My name is Marleen Riemens from Weur in the Netherlands. This video is part of a module 3, Integrated Weed Management, Chapter 6. In this video, a case study of integrated weed management for arable vegetable farming will be presented to you. In the Netherlands, we work together with our research partners to design a crop management system that prevents diseases, pests, and weeds as much as possible. In this way, we hope to provide farmers with a cropping system that is able to meet the requirements of the farm to fork strategy, to reduce the use and risk of chemical pesticides by 50% and the use of more dangerous pesticides by 50% in 2030. We effectuated the term more dangerous pesticides as the substance on the EU candidates for substitution list. The work is performed in long-term research that started in 2018 and that will run to the end of 2028. In this research, we make use of the integrated weed management framework designed in the previous EU Horizon project IWM-PRAISE, which is also presented in Chapter 2, the principles of integrated weed management in this module series. This framework for integrated weed management starts with the life cycle of weeds. Here you see a simplified representation of the life cycle: seeds, seedlings, and adult plants. Each step in the life cycle can be interrupted with tactics and tools. If you notice the colors, they indicate where the weed life cycle is interrupted. Gray measures prevent competition between crop and weed. Orange measures reduce multiplication of the weed. Green measures prevent establishment of the weeds. And in a more general sense, these colors and control handles can also be applied for disease, insect, and nematode control. To each of the pillars, tactics and tools belong that hamper the life cycle of weeds. And do you remember the three colors of the life cycle? These are visible here again: the green, the orange, and the gray. As an example, you can see planting and sowing date in the cultivar choice pillar, and on mechanical weeding in the targeted control pillar. The red triangles are supportive tactics for monitoring and decision making. So combining tactics and tools from different pillars and different colors diversifies your weed management strategy and therefore your weed population, which will reduce the chance of dominant, highly adapted weed species in the cropping system. Similar frameworks were developed for insect management, nematode management, and disease management, and together they form the integrated crop management framework, an elaborated version of the IWM framework for diseases, pests, and nematodes. So together, these form integrated crop management. And this integrated crop management framework is used to redesign crop management systems and strategies in this case study. The resulting cropping systems are tested for their impact on yields, use of pesticides, economic costs, and prevailing pests, diseases, and weeds. We compare that system with the reference system, where crop protection is performed as in current conventional practice. In the ICM system, we integrate tactics and tools from the 5 pillars of the IWM system. So, in this system, I repeat, we do not use candidates for substitution, the so-called CFS. So, here you can see the strategy for weed management that we applied in these systems. In this case, some hexagons are hidden and others are highlighted. The highlighted ones are the tactics and tools that we combined. And as you can see, we combined tools and tactics from different pillars, and they also have various colors. And in this way, we diversified our weed management strategy. And we did the same for the pests and diseases and nematodes. The experimental setup is as follows. The basis for the strategy is a diversified crop rotation. We have chosen our crops based on their relevance in the region, for instance, crops that fit nematode and soil fungi control in the specific field, and crops that are economically interesting. In this case, potatoes are grown once every 4 years because of their economic importance in the Netherlands. We choose varieties that are resistant to the nematode Globotra pallida. In potatoes, we also have good options for mechanical weed control. In sugar beet and maize, we have good opportunities to control potato volunteers. And furthermore, we have a cereal crop, either winter barley or summer wheat or summer barley, carrots, cabbage, and seeded onions in the rotation. The biggest challenges in this rotation for weed management are the carrots and the onions because of their openness in the early stages of their development. This 8-year ICM rotation is compared to a reference rotation of 4 years, where crop protection is carried out as practiced on conventional farms in the area. This rotation consists of potato, seeded onions, a cereal crop, and sugar beets. In addition, 2 intermediate cropping systems are tested. An 8-year rotation, in which crop protection is performed as it is in conventional farms, and the 4-year rotation, in which as many measures and methods from the framework as presented before are used. I said that this work is running since 2018, and what you can see here are the first results and the effects on these systems on the wheat seed bank. So on the y-axis, you see the average number of wheat seeds per sample, and on the x-axis, you can see the year and the strategies, either the 4 and 8-year ICM rotation in green and the 4 and 8 reference rotation in blue. As you can see here, there were no significant differences in the size of the soil seed bank between the strategies, although there seems to be a trend of a small increase in the ICM wheat seed bank. In this graph, the crop yields are depicted for the first 4 years. On the y-axis, you see the yields in tons per hectare of the crops in the ICM system, and on the x-axis, you see the reference yields for the same crops. The black X-Y line indicates equal yields in the reference and the ICM systems. Dots below the black line mean that the yield in the ICM system was lower. Dots above the black line indicate higher yields in our ICM system. This graph shows that in some cases yields were higher in the ICM, and in some years and for some crops they were equal, and in others they were lower. For crops such as sugar beet and potato, the variation is highest, and the reason are mostly fungal diseases such as Phytophthora infestans, Cercospora, and Alternaria. In many cases, the weeds were not the issue. So if we look into the results of this case study, we see as a downside that on average the lower crop yields. As a benefit, we see that we have no use of these candidates for substitution pesticides. The average reduction of pesticides was 50%, and also the environmental impact could be reduced. The implications of this system are that this system is more knowledge intensive, and we need decision support systems. It's a possibility of a change of market because we have a widening of the crop rotation, and we need precision mechanical weeding to reduce the labor. I would like to thank you for your attention.